Hi, my name is Brendan Morrell, and my team did the hydrogen fuel cell, and the other team members are Stephen Tanton, Rafael Meza, and Eduardo Nacianceno.
We will first discuss hydrogen as an energy source. Hydrogen can be extracted from fossil fuels or can be produced by using the process of electrolysis to split water into hydrogen and oxygen. Both of these processes require an energy input. This energy can be provided by fossil fuels or by renewable sources of energy such as solar or wind. The hydrogen must be kept in a suitable container until it is ready to be used in a fuel cell to produce electricity. Hydrogen is an excellent material to store energy. It is much cheaper than traditionally used fossil fuels such as gasoline and diesel. Hydrogen fuel cells have a greater average efficiency than do combustion engines, although they have very high manufacturing costs. They are potentially less reliable under extreme conditions such as high temperatures and high pressures and must be evaluated further.
Sir William Grubb demonstrated the concept of the fuel cell in 1839. However, it was not until 1932 that Francis Bacon developed the first successful fuel cell. Limited progress was made over the next quarter century. The pace of development increased around the time that NASA began to research the technology for use in the Gemini and later the Apollo programs. Fuel cells are also used in the Space Shuttle fleet.
We will now cover a little bit of the theory behind how a hydrogen fuel cell works. The process begins with electrolysis. Electricity decomposes water, usually in a Hoffman apparatus, to form oxygen and hydrogen gas, which are used as the fuel. The fuel cell chemistry. At the anode, hydrogen gas is stripped of its electrons, yielding 2 protons and 2 electrons. These electrons are the energy utilized to power machinery. The reaction that occurs at the anode is shown below. The protons then pass through a PEM, an electrolyte that is an electronic insulator and reactant barrier to H2 and O2. The protons then reach the cathode where they are allowed to react with oxygens and free electrons to form water. This water is a byproduct and is not needed. The reaction at the cathode is shown below.
So this is how it works. The picture in the center shows the setup of the entire experiment. The process of producing electricity goes from left to right. First, the 2 tanks, one on the left and one on the bottom center, are filled with distilled water, and the electrolyzer and PEM fuel cells are dampened as well. First part is producing hydrogen. Water from the tank on the left makes its way into the electrolyzer by way of gravity. The power from the sun splits the water molecule into hydrogen and oxygen. While the free oxygen molecule is released into the air, the hydrogen makes its way into the middle tank. The hydrogen also displaces water that was in it and pushes it to the tank above it. Once the bottom tank is filled with hydrogen and all the water is above it, we then shut off the valve between the hydrogen tank and the electrolyzer. The next phase is utilizing hydrogen to make electricity. First, we open the valve between the hydrogen tank and the fuel cell. The water above the hydrogen tank pushes the hydrogen by way of gravity into the PEM fuel cell. While the hydrogen is being stripped off of its electron to make electricity, the free hydrogen then comes in contact with oxygen in the air to produce water as a byproduct. The electricity then turns the fan. So a typical hydrogen fuel cell produces about 0.5 to 0.8 volts per cell. The picture on the bottom left shows us conducting the experiment outside where the water was producing hydrogen. The bottom center picture shows the fan as our electrical load to test the functionality of electricity. The monitor on the bottom right shows the readings of our current and amperage, which is attached to our volt and ammeter, which are then attached to our terminal from our electrical load, which is the fan. Overall, the experiment was a success, even though we had a delay in which we forgot to dampen the actual PEM fuel cell and resulted in no power output. Once corrected, we had to come back and finish recording our data.
The recorded values produced in the bottom left plot shows how much hydrogen was produced during the first part of the chemical reaction. This part of the experiment required the irradiance from the sun to be at least 1000 watts per meter squared for all sets of 5-minute intervals. It was noted that the container holding the distilled water dropped in volume as the process occurred. Following the separation of the hydrogen from the water, the reaction of hydrogen mixing with oxygen in turn produced power, which can be depicted in the wattage produced by the H2 plot in the bottom right graph. One thing to notice was that the irradiance decreased. As the irradiance decreased, so did the power consumed in the experiment. The power produced by solar plot clearly depicts this linear relationship. Taking the product of the irradiance at the specific time interval and the area of the solar cells yields the power in parameter, which can be seen in the top left table. This value stayed consistent for all 5-second intervals and slightly varied based on a few clouds passing by as the chemical reaction occurred. The parameters for the power output can also be depicted in this table. Lastly, after figuring out the power input and power output values, the efficiency of the hydrogen fuel cell could be calculated for all 5 sets of intervals. These percentages conveyed that the hydrogen fuel cell was not very efficient. This means that although the fuel cell is a renewable resource, it requires charging. In this case, this specific hydrogen fuel cell model studied could produce enough power to operate a small fan, which acted as the electrical load for our experiment.
So to get a better idea, we compared an internal combustion engine to a hydrogen fuel cell or electrical vehicle. And for the internal combustion engine, fuel is burned, which causes a great amount of gases to be produced, and which will then cause pistons to start moving. So for this stages, it includes going through chemical to thermal, and then lastly to mechanical energy. For the fuel cell, the hydrogen fuel cell vehicles use hydrogen gas to power an electric motor. Unlike conventional vehicles which run on gasoline and diesel, fuel cells are used oxygen and hydrogen to produce electricity, which will then run the motor. And for these stages, it includes chemical, electrical, and then mechanical last. We will now compare some real-world examples of hydrogen fuel cells. For example, we included 2 different pictures, one out of a Chevrolet truck and two Toyota Mirai. For the Toyota Mirai, hydrogen enters the vehicle by the fuel port. The hydrogen then releases its valence electrons, which produce electricity. Electricity will then send power to the control unit, which will then send signals to the motors and other components to start working. During the process, oxygen from the air intake and hydrogen will then meet at the fuel cell stack, in which will create small droplets of water that is then exhausted from the vehicle.
So in conclusion, using solar energy to make hydrogen fuel cell deemed to be inefficient, economically, being able to use free and abundant resources is better than paying for hydrocarbon fuel sources. However, hydrogen fuel cells are currently expensive to manufacture. Many hydrogen fuel cells would be needed to produce a significant amount of usable energy.